Hi everyone, and welcome to our lesson on work. In the theory videos, we've basically defined work as putting energy into a system. But you can also do work, say, against kinetic energy. So in some cases, work is actually taking energy out of a system. In any case, doing work changes the energy of a system. And in physics, we define work as a force acting over a distance. So we can set up a problem like this. A 50 kilogram box is moving to the right, but it starts at rest, but it's being moved to the right by a force, here I'll do it in green, of 300 newtons. And that force will act to accelerate that object, since there's no friction on this surface yet. And the box, or the object, is moved a total of 2 meters to its final, not resting place, the place where we are looking at the box captured in time. So by the time it's covered that 2 meters, this box will be traveling with some velocity, since it is being accelerated by that force. The question could ask us, what is the velocity of the box when it reaches this point here? Turning for a moment to our motion formulae, we have V equals U plus AT. Now we know U, we could figure out the acceleration, but instead of knowing the time in which the force has been acting, we know the distance in which the force has been acting. So we have two unknowns here, V and T, and that makes that formula pretty useless to us. What we can use is our understanding about energy to find the velocity of the object there. So work is equal to force times distance, and the kinetic energy of an object is equal to a half mv squared. So a half mass times the velocity squared. This force acting over this distance is doing work. Let's calculate that work first. So the work done by that force is equal to force times distance. The force is acting in the same direction as the distance being covered. So we get a total of 300 times 2, 600. Now work is a measurement of energy, so it's in joules. So 600 joules of work is being done to this box over here. And that changes the amount of kinetic energy that box has. So that's equal to the change in energy. If this box started out at 0 meters per second, started stationary, then the initial kinetic energy is 0. So the final kinetic energy is equal to the initial plus the change, which is equal to 0 plus 600 joules. That just tells us if we start with 0 and put 600 in, we end up with 600 joules of kinetic energy by the time the box gets to that point there. And that must be equal to, so kinetic energy is equal to a half mv squared, so a half 50 v squared, getting v squared by itself, 600 times 2 over 50 equals v squared, or the square root of 600 times 2 over 50 is equal to, I have here, 4.9 meters per second. Let's verify this using one of our motion formula equations. V squared equals U squared plus 2AS. So let's figure out the acceleration first. F equals ma. 300 is equal to 50 times a. 300 over 50 is equal to 6. That's the acceleration. 6 meters per second squared. So v squared, which we're trying to figure out, is equal to u squared, that's 0 squared plus 2 times 6 times 2. V squared is equal to, that's 1224. V is equal to the square root of 24. Which comes to around about 4.9 meters per second. So there were two ways of finding out that velocity, but we're using the energy and work method here. Let's make this question a little more complicated. We said work can either add energy to or take energy from an object. Let's say here there is, we'll say 100 newtons worth of friction. I'll draw that in yellow. 100 newtons worth of friction acting on this object here, even though it is being dragged. Since there's more force pulling to the right than to the left, we do expect this object will be pulled this way, and the frictional force will oppose that motion. So the work done over that 2 meters by this force has not changed. The work, we'll call that by the driving force. Driving force is still 600 joules. Let's figure out the work done by friction. Well, if the force is acting in the opposite direction to the distance traveled, so distance being that 2 meters of horizontal displacement here, then the force is actually negative. So it's negative 100 times positive 2 meters. So we get negative 200 joules. So now we can calculate what the net work done to that object was. That would be 600 plus negative 200, or 400 joules. And now we know that the total work done by both those forces is 400 joules. We can say that was equal to the change in energy, which is also equal to the final kinetic energy because it started out with no joules, which is equal to a half 50 v squared. Getting v squared by itself, we have, so I'll make that clearer, 400 is equal to the kinetic energy, so 2 times 400 divided by 50 is equal to v squared. Getting rid of that squared, we have the square root of 800 over 50 is equal to the square root of 16, 4 meters per second. So work can either put energy into an object or take energy out of an object, depending on whether it's acting in the direction of motion or against the direction of motion, like so. There'll be more complicated videos on work coming up, including when the force is acting not directly in the direction of motion, as in this case, but at a slant. So that'll be covered in the next video.